Okay, welcome back. We're going to be looking at Unit 3, which is quadratic expressions, and specifically by the end of this unit we should be able to interpret and solve questions related to quadratic relations. And what we've been learning is about expanding and factoring, expanding binomials and factoring trinomials. And before we begin, this is just a brief recap of expanding and factoring. We're going to be using part 2 and part 3 of these 4 expansion and factoring portions, and just to recap that, going this way is expanding and going this way is factoring. And what these are called are perfect squares, and these here on the right side is a differences of squares, and a difference because it is subtraction. What we're going to do is we're going to take a look at a few problems that you should be able to do at this point, just to be sure that we're on the same page, and it was also going to help us understand what's going on in this lesson. So we're going to expand and simplify, and at this point I'd encourage you to pause, take a few minutes to try and do these questions before we take them up. This one here is equal to x squared plus 2 plus 2 is going to be 4x plus 2 times 2 is 4. And that's coming from essentially x plus 2 times x plus 2. And you could use the FOIL method, or you could use a shortcut of adding these two numbers to get the middle coefficient and multiplying these last two numbers to get the final coefficient. This one isn't as easy because we've got this 3 and the 2 with the x and the y. But essentially what you've got is 2x minus 3y times 2x minus 3y, but it's also like saying that's a and this is b, so we could almost use a shortcut, which is this is going to be a squared minus 2ab, and that's going to be plus b squared in the end. So if I wanted to use a shortcut, this is going to be 2x squared with the brackets on the outside minus 2 times 2x times 3y plus b squared, which is 3y squared, which is going to be equal to 4x squared minus 2 times 3, which is minus 12xy, plus 3 times 3 is 9, and it's y squared. This here is a difference of the squares because it follows this idea of a plus b times a minus b. In this case, the a is the x and the b is the 4, and this is equal to a squared minus b squared. In this case, this is a, this is b. So this is going to be equal to x squared and b squared, which is 4 times 4, minus 16. This also follows that same idea. This is a, this is b. This is equal to 2x squared minus 5y squared, which is equal to 4x squared minus 25y squared. So that's a quick review, and yes, I've used the shortcuts for a reason, because it's going to help us with what we're doing here, which is factoring perfect squares and differences of squares. Our overall learning goals for this lesson will be to factor polynomial expressions involving common factors, specifically trinomials and differences of squares for this lesson. And I know that I've met my learning goal if I can factor expressions like these ones here. These are differences of squares. These ones here, these last three, are perfect squares. And notice that they get progressively harder as they go, and we'll do the same in this lesson. Some key terms just to go through. Perfect squares trinomial is a plus b squared or a minus b squared. And we've got this expansion, which will show that a plus b is equal to a squared plus 2ab plus b squared. And the only difference between these two, when you got a minus b squared, is that this middle term here, the middle coefficient, is negative. This here is a differences of squares. It's a square minus a square, and it's equal to a plus b times a minus b. And something which is also useful is to know perfect square numbers. So we've got 1, 4, 9, 16, 25, and so on and so forth. You should know these numbers, and it's going to help you in this lesson. Here we've got our first example, and what we need to do is factor them. And I'm going to show you how to do the ones on the left before I do the ones on the right. One thing I would like to do before you guys try to do these questions is change this to 169, because I forgot to change it from this question on the left. At this point, I'm going to look at this question here. This one technically can be done just like any other one. Two numbers that add to 10 and multiply to 25. Those numbers are 5 and 5. 5 times 5 is equal to 25, and 5 plus 5 is equal to 10. So we can just use that to find this. And this is considered to be a perfect square because this is x plus 5 squared. Now, notice here that this should be your final answer because this here is not factored fully, because when you have a squared here, it says that you can actually expand it. So when you give a final answer, it should be actually the very first line. I'm just showing this bottom line just so to emphasize that it is a perfect square. This one below is a differences of squares. The way I'd write this is bracket x squared, and 121 is 11 squared. And so it emphasizes that this is going to be x plus 11 and x minus 11 multiplied together. X plus 11 times x minus 11. And you could also write it the other way, which is x minus 11 times x plus 11. Both would work. On the right side, give you a few minutes to go through these questions. Pause the video at this point, and then we'll take them up. At this point, we can see that two numbers that multiply to 36 and add to 12 are negative 6 and negative 6. So this is x minus 6 times x minus 6. Below we've got a differences of squares. This is equal to x squared minus 13 squared, because 13 squared is going to be 169. So this is equal to x plus 13 times x minus 13. We're going to get progressively harder on the next set of slides. These ones now start to have numbers in the front and the back, and now we've got these variables as well, and it's a little bit more complex than just saying, well, what adds to this and multiplies to this. We actually have to know the rules, and I'm going to teach you that. So what I would start with first is, I know that 25 is a perfect square. That's 5x squared minus 120xy. And 144 is the same as 12 squared, so plus 12y, put the bracket squared. And so if I want to verify that this is a perfect square and that I can in fact factor it, then all I would do is 5 times 12 times 2, because ultimately if you look at the expansion of this thing, it's 2 times a times b, and these numbers would be, well, there's the 2 times a times b. 5 times 12 is 60, 60 times 2 is 120, which it does work. Notice that this is also minus, so on our end we're going to have a minus inside, so this turns into 5x minus 12y squared, and that's as far as we can go. And we know that we can do that because that middle term, 5 times 12 times 2, is 120. This is a difference of squares, and I'm going to write this as square root of 49, or 7 times 7 is 49. 7x squared, and 15 times 15 is going to be 225. So that'd be 15y, put the square on the outside of the bracket. And so as a difference of squares, this is like saying this is a plus b times a minus b. So this will be 7x plus 15y times 7x minus 15y. this point, I'd encourage you to pause the video so you can try and do these two questions on your own before I take them up. This is equal to 13x squared minus 234xy plus 9y bracket squared, because 9 times 9 is 81. The squareds are on the outside of the bracket. Let's check to see if this is in fact a perfect square. We can go 2 times 13 times 9. 9 times 13 is going to be 90 plus 27, which is 117. 117 times 2 is 234. So yes, this is a perfect square. We got this minus, so this is going to be equal to 13x minus 9y bracket squared. This last one, 11 times 11 is 121, so 11x bracket squared. This is 6 times 6 is going to be 36, so 6y bracket squared. And also notice, if you tried to common factor any of these numbers, nothing divides 25, 120, and 144. And in that case, that's why you can also, you should be trying to common factor everything first, but if you can't find any common factors, then you should be looking at whether or not it's a perfect square or differences of squares. This is going to be equal to 11x plus 6y times 11x minus 6y. And we're done with that. That's it for this lesson. I would encourage you to do these questions. These are mostly application problems. But if you feel that you need a little bit more practice on the process, then I'd encourage you to do page 254, numbers 1 to 5. And that will go through more of the things which we've done in this lesson. The next lesson that we do for this unit should be focused on application problems. Again, thanks for watching. Practice makes perfect, and math is not a spectator sport. Thank you.